The surface of our planet is becoming a graveyard for traditional computer hardware. The reality is fiercely physical. It is millions of pounds of metal and silicon, and right now, that physical infrastructure is burning up. The immediate threat to these systems is artificial intelligence. Running complex AI models requires vast amounts of electricity, astronomically more power than simple web hosting or a standard search query. Look at this diagram showing how an AI processing chip handles that electricity. Almost 100% of the massive energy flowing into this hardware converts instantly into radiating, suffocating waste heat. We are dealing with a severe thermal bottleneck. The sheer volume of heat generated by the AI boom is actively threatening to melt the servers backing our global network. To keep that hardware from baking itself to death, surface-level data centers currently dedicate up to 40% of their total electricity consumption strictly to cooling systems. But those surface facilities are losing the battle against extreme weather. When atmospheric temperatures spike past 40 degrees Celsius, like the intense heat you see requiring outdoor misting systems here, traditional methods of pulling in outside air to cool the servers become mathematically useless. Operators are forced to rely on massive mechanical chillers. A single hyperscale data facility can guzzle up to 2.5 billion liters of water a year just to avoid a thermal shutdown, creating massive environmental and economic costs. Combine extreme global temperatures with the extreme processing demands of AI, and you hit a hard limit. Right now, running massive tech hubs on the surface of the Earth is quickly becoming an impossible thermodynamic liability. To save the network, tech giants are executing a massive geographical retreat. They are abandoning the surface and pouring billions of dollars into deep underground caverns. They are banking their infrastructure on a geological property known as subterranean thermal inertia. Look at this cross-section of the Earth's crust. While the surface absorbs wild weather fluctuations, digging down just a few meters reveals total stability. The deep rock maintains a permanent ambient temperature between 10 and 15 degrees Celsius year-round. By burying servers down in these cold chambers, engineers can use the Earth's crust itself as an infinite thermal sponge. The massive heat output of the hardware dissipates safely into millions of tons of solid rock. By isolating these facilities geologically, they completely bypass the warming atmosphere above. It eliminates the need for giant outdoor air conditioning units and slashes the energy required for cooling to nearly zero. Engineers are already executing this infrastructure shift across Europe and the United States. In Switzerland and Norway, tech companies are installing vast server clusters deep inside former military bunkers, carved straight into solid granite mountains. They draw naturally freezing glacial water from the surrounding geology and pump it through closed-loop pipes. It cools the machines naturally without requiring a single drop of chemical refrigeration. Over in the United States, the Department of Energy is currently funding projects to repurpose flood-in abandoned coal mines for the exact same cooling strategy. Inside these massive subterranean spaces, operators pump naturally chilled water from deep underground pools. They run it past the hot servers and immediately re-inject it into the earth to cool back down. It creates a perfectly circular loop that consumes no net water. To stabilize the most advanced artificial intelligence on the planet, we have to rely on the oldest, most permanent geological formations we have. Swapping out complex mechanical engineering for raw geological mass directly solves the massive heat and energy bottlenecks suffocating these processing chips. This points to a permanent shift in how we build global networks. If absolute privacy, climate resilience, and strict operational survival are required, the servers keeping the internet online belong deep in the bedrock. It creates a striking irony about our technological trajectory. As our collective intelligence pushes towards its highest capabilities, its physical survival depends on being buried deep inside the abandoned ruins of our industrial past.